Today, we are thrilled to speak to Teresa Liu, co-founder and CEO of Ouros Materials, a company revolutionizing the construction industry with sustainable carbon-sequestering materials. Teresa is based in New York, United States, and holds a bachelor degree in computer science from the University of Southern California, USC. During her time in the USC, she was recognized as a Dean's Merit Scholar and was actively involved in entrepreneurial initiatives, serving as the president of Spark AC to empower student entrepreneurship and as a tech lead for Code the Change, building software for nonprofits in Los Angeles. Teresa is also a 776 Foundation Climate Fellow, which catalyzed the journey of Ouros Materials. Teresa, welcome to Climate Quest. We are excited to have you here to talk about sustainable construction, entrepreneurship, and your journey to co-founding Ouros Materials.
Thanks for having me.
Can you briefly introduce yourself and share what inspired you to start working in the climate space?
Yeah, sure. So I'm Teresa. I'm the co-founder and CEO of Ouros Materials, and we're commercializing a new building material that is this new invention out of Rutgers University. It has some really amazing properties like being 100 times tougher than normal concrete. It's ultra fire resistant, it's ultra tough and strong, and has the ability to be used versatility across a lot of different applications in building materials. And so we're commercializing it with a serial professor and entrepreneur over at Rutgers University. So that's the basis of the company. I'm happy to dive into how I started the company. But as a bit of background, I got into the climate space because I've always been very motivated by social impact. And I grew up in suburban Pennsylvania and had always been very starry-eyed towards the world of technology. That was the reason why I moved to LA and studied computer science and did all these entrepreneurship activities at school. But then when I started working in larger big tech and corporate, I just realized that a lot of the problems that we were solving in traditional tech industry wasn't aligned with some of the huge core problems that were out there in the world, like climate change and education and health were so important to me. And I really wanted to figure out a way to get into those spaces and figure out what was my journey towards making impact. And I didn't expect to end up in the material science space, to be fully honest. Looking back, it makes so much sense because all of climate is a core chemistry, bio, and chem problem, but it's definitely navigated me towards a really interesting journey and so excited to be working on something that has so much potential for impact now.
Absolutely. And such a cool journey from corporate and realizing that there was this gap.
Yeah.
Can you give us a little more color on how you spotted the opportunity and found out about this research being done at Rutgers?
Yeah, for sure. So like I mentioned, I was working as a product manager out in the tech industry, was working at Lyft, and I ended up getting the 776 fellowship, pitching a totally different idea in the software electric grid space. Realized it was a really tough, terrible problem, terrible market to solve. There was a lot of startups that were doing really great work in that area already. 2 months into 776, which is a 2-year fellowship, by the way, I just had this realization that I was like, okay, what am I doing? I have no idea what I'm doing with this fellowship. I should really figure out from a high level, what are the problems I can solve and create a plan on how to solve them. So I ended up talking to a lot of different entrepreneurs, one of which connected me to a program called LabStart. And LabStart is this program that helps underrepresented minorities in the tech space to commercialize really interesting national lab IP. And I thought this was a super interesting approach because the amount of research funding that these national labs and universities get to very much just tangibly work on climate change and carbon emissions and sustainable materials, recycling plastics, all of this funding gets put into research, but there's this huge gap between what happens at research labs and what actually gets commercialized out in industry. And so I was like, oh my God, there's kind of this gold mine of really amazing inventions at these labs. And if I can be the crazy person to just spend so much time, so much of my life just focused on commercializing that, then I can make a really big impact. So I was basically like, okay, I'm going to focus on industrial decarbonization. I'm going to go really wide and talk to all the researchers in sustainable concrete and materials. So did this really broad IP search across a lot of different national labs like Pacific Northwest, National Renewable. And then ultimately I was at this conference in New York City where I met my current academic co-founder, Professor Rick Riman. And when I first met him, he is such an energy he's such a visionary in the carbon utilization and sequestration space. And you don't really realize it until you talk to him. And he just has such a wealth of knowledge from starting companies like he's the co-founder of Solidia, which was 1.0, which raised over $100 million from like Kleiner Perkins and Breakthrough. And I was like, okay, this guy is a very legitimate guy. He's really just such a prolific inventor and a really great person to have on board. We started working together about I want to say 2 years ago. We had our first serious conversations, and then I did a bunch of market discovery to figure out where is this new carbon utilizing composite technology really interesting. Targeted the built environment just because there was so much potential for concrete and cementitious materials to capture a lot of CO2. And then we brought on our CTO, Dr. Sharon Tracy. And so that's kind of the founding journey. I think what's really interesting about the tech in general is that we're not just a green concrete, green cement. We're making something that is a really tough new composite material that has incredible performance advantages and low costs. So that's really our thesis to commercializing this new technology, where we're making something better and cheaper, in addition to sneaking in some commercialization and being the most sustainable material in the built environment.
Yeah, I can imagine the built environment is a tough one to crack as well because there's so many established players and they have their ways of doing things. What are some of the challenges you face since you started, and how did you go about overcoming some of those?
Yeah, that's a great question. I think there's a couple pieces. The first is that the construction industry is very segmented, and so it's really hard to figure out who is the key purchaser and influencer in the construction industry that you would sell to. And we have a go-to-market strategy for this where first we're talking to architects who directly specify the material and can direct decisions that way. But ultimately, we need a really large buyer. And the large buyer could be, say, like a large corporate real estate developer or potentially like a general contractor who chooses materials. But it's not like a very clear like supply chain. So getting that first customer is going to be really difficult. And we need that to like get into distribution, where distribution is the major way you push out a lot of materials. Either that, or we could go to a manufacturer who could partner with our development and go through their distribution channels. So the go-to-market in construction is tough. Plus, you have all the building codes and regulations. It's a very risk-adverse industry for very good reasons. Like you don't want to be building buildings with brand new materials all the time. And so that's partially the reason why we're going after like really simple like interior finishes or countertops as a way to enter the market without a high safety risk, and then slowly penetrate into structural and exterior applications over time. So that's some of the go-to-market strategies and some challenges we face. I would say on the other side, quite frankly, like the funding environment is not great for deep tech right now. And I think a lot of pre-seed companies are feeling that right now, where there just isn't as much appetite from both the changes in the administration and from the general climate tech sentiment to invest in really early stage deep tech. And so we're getting around that by tapping into every single non-dilutive funding piece we can find. So there's some really great funding from the university itself, Rutgers, New Jersey, New York State has some really great resources, SBIRs. We got some non-dilutive funding from the JLL Foundation recently, which is a major real estate services company. And so we're really happy to have them on board. So it's really just like the classic getting scrappy, figuring out how to make it happen and going from there.
Yeah, and showing a lot of determination and persistence. So I heard a good quote that 1% is having the vision, 99% is the execution. So you're definitely in that. You mentioned some really great resources and some partners you have on this journey. Were there are any other folks or things that were helpful for you as you were getting started and now that you're further along?
Yeah, I think one of my biggest learnings during this journey has been how to ask for help and how to leverage a network of mentors and other entrepreneurs. When I first started the journey, I didn't know anything about IP commercialization or like techno-economics or how to even scale materials or deep tech. And I find myself just being really good at asking questions, and at this point, asking for help for anyone I can get my hands on who are really experts in, say, go-to-market strategy or business development or IP related work. So I think a lot of it is you just learn from being in the climate tech ecosystem and asking other entrepreneurs and mentors for help and being very explicit around, okay, like this is the very specific problem we're having. have you encountered this? Is this something that you can help with? If not, can you connect me to someone who is facing this problem? And also just the energy that you get from talking to other founders about your challenges. They really just whip you into gear about like, okay, your market is wrong. Like, go figure out your market, then go pitch, or this about your pitch like needs to get fixed. And having this direct communication is really helpful because it just gets you really focused on what your priorities are to get to the next milestones and succeed. So I think that was one of my biggest learning curves.
Yeah, build the right people around you, definitely an important piece of the puzzle. You've done all kinds of things, even in university around entrepreneurship. You worked for some really great companies. What do you think is different around climate entrepreneurship versus maybe a regular software startup or a material startup, if anything?
So climate tech itself is a really cool ecosystem because all the founders are really supportive of each other. And most of it's like, we're not really competing in the same spaces. Like there will be chemicals companies and there'll be biotech companies, but the scale up journey is largely the same where you're selling into a very complicated and conservative supply chain. You have to do all the equipment sizing up and working on all these similar challenges. So everyone in climate tech, because we're all working towards the same social impact goal, is just so nice and so supportive. And I get so much energy from just talking to other founders about their solutions and their like wild, mad journeys as well. And then there's this shared, suffering of fundraising hard, or we have such a cool vision and it's so important, but it's so hard to get to. So there's a lot of that. So I love all the other founders and like people supporting the climate tech ecosystem. Mm-hmm.
So love to also hear that from you. Next, we also want to talk a bit about KPIs and impact. As that for your materials, how do you quantify the impact that you have? Do you go by avoided, like reduced emissions that you need for the materials? What do you try to measure?
Yeah, so we try to measure CO2 avoidance as much as possible, and then also CO2 utilized into the technology itself. Because we are curing our materials with CO2 during like the curing step, we capture roughly, like for every 1 kilogram of material produced, we capture roughly 0.3 kilograms of CO2. So we make sure we're on target to have a high utilization rate for our material, and that drops down our carbon footprint. The part on CO2 avoidance is really interesting because we're replacing high embodied carbon materials, but because there isn't a very clear one-to-one replacement, because we're a new material, there's a lot of different materials we could be replacing across like concrete, cement, ceramic, tile and brick, steel maybe one day, who knows. There's also like replacing wood or like laminates, and in those areas it becomes way trickier to figure out the avoidance impact. So once we get really refined and crisp around our application set and say like we're replacing so and so most of the time, then we can have a really strong argument around CO2 avoidance. And so we track CO2 avoidance and carbon utilization per unit of material produced, and then we also just want to track total utilization and avoidance and make sure we're on track to have a really high impact as we scale our technology.
Can I jump in with a curiosity question? Where is the carbon sourced from? Because we didn't talk about that yet.
Yeah, it's a great question. So we're solidly within the carbon utilization side of the ecosystem. There's the whole like direct air capture and carbon capture ecosystems that are concentrating the CO2 from flue gas streams or from the atmosphere itself. We take that concentrated CO2 and utilize it. And so we would either transport in CO2 from these sources or co-locate our facility with a system that does the capture for us, or potentially license the tech or work very directly with like flue gas one day. But we're really focused on creating a really strong market pull for CO2 and our material, because it's a premium product and we can sell at a couple $1,000s per ton, but we can absorb really high prices for CO2. So the whole idea is like, can we pay like up to $1,000 per ton for CO2, which is right now where the price of carbon capture and direct air capture are sitting today, such that we can create this huge demand and incentive to pull CO2 and use it for our high value building materials.
You can charge a price premium because of the CO2 avoidance that the companies are ready to pay? Or how are you thinking about the profitability, like medium term? Is it already working, or do you have to like lower the price for the customers?
Yeah, so There's the CO2 prices that we're able to afford, and then there's our end prices. So for CO2 prices, there's a lot of companies that cure concrete and like cement with CO2, but the tricky part there is that concrete only sells for like $80 to $160 per ton, and so you're not able to absorb a high price for CO2 without charging a green premium. Whereas because we're selling a advanced composite material that has all these performance advantages like the really high toughness, we can sell into a more premium industry like polymer-based composite materials and be able to sell at a couple $1,000s per ton. And so we can afford really high CO2 without a premium and without carbon credits. On the flip side, our product today, because everything is at small scales, we have a long-term economic analysis that says that will be half the price of a lot of different polymer-based composites or like fiber-based cements and concretes. But we really need to demonstrate the de-risking of our manufacturing and sizing equipment and securing large volumes of feedstocks in order to get to that long-term cost target. But I would say like from just our technology itself and what it enables in terms of using a lot of inexpensive feedstocks, there's a really compelling argument that our materials are way cheaper than competitors.
Cool. And you already mentioned in passing carbon credits that are not even part of the equation now, so they could come in to make it even more attractive?
Yeah, eventually. This is an area that we haven't gotten super into just because carbon credits are abstract as a product. It requires a lot of like verification and measurement and like partnerships with direct air capture companies. So eventually like, the vision is that we would partner with say like a direct air capture company who needs a storage mechanism. They can handle probably the selling of the carbon credits, or that's potentially something we could look into if we do the direct air capture or carbon capture ourselves. But our main focus is creating a very natural economic incentive based on the sales of the product of this material and making sure that has really strong economic value before introducing these different carbon credit incentives.
That makes a lot of sense. That's great. Thank you. Maybe as some of the last questions for other aspiring climate founders in the audience, do you have any tips for people who are just starting out? You already talked about how to maybe scope for ideas, but anything else you want to point them to?
Yeah, I would say definitely find mentors who can guide you on this journey and then just keep going. Don't give up. I think climate is one of those things where the timeline to impact is at least twice as long. And there's always the shiny object of, I could have built a software startup and had profitability within like a year or so and like raised all this money. But I think climate is so important. And I think that's why all the founders like have stuck in the climate space and like have stuck out really tough journeys. But it is a really tough journey and it's really long. So make sure you have like a good support network, both in terms of family and friends, but also just people you can learn from and rely on to go through the tough times and really figure out how do I need to succeed to like grow this business and have the ultimate impact you want in the world. So yeah.
Amazing. Teresa, that was the perfect end statement to motivate more into tough and climate tech and build real things. So
also want to say thank you from my behalf. This was a really inspiring conversation.